All right. Hey, everybody. So we're continuing to talk about limits and limits of functions. And we saw a little bit about their definition. We saw a little bit about sort of the mental image we have in our head, but we still haven't seen an example of how to rigorously show that a limit of a function is what we expect it to be. So here is a simple first example. We have our function f of x equals 4x plus 1. X. And our goal is to show that this the limit as x approaches 3 of f of x is equal to 13. Now, as a reminder, to rigorously do this, what we need to do is we have to show that for every epsilon, there exists a delta, right? For every epsilon greater than 0, there exists a delta greater than 0, such that if x is in the domain of our function, and we didn't really say this before, but f of x is going to be a function from R to R, so any real number is a valid element of this domain. So if x is an element of the domain, in other words, if it's a real number, and if it satisfies x minus p is less than delta, so in this case that's x minus 3 is less than delta, then we can conclude that f of x minus L is less than epsilon. Just sort of squeeze that in there on the side. Okay, so that is our goal. That's what we're trying to show. So the way that we might start this, right, sort of as far as a structural or a structure for our proof, as far as our structure might go, we'll start with an arbitrary epsilon. We'll choose a delta based on that epsilon. So we'll say something like, let delta equal epsilon over 2, let delta equal epsilon, but we'll define a delta based on the epsilon. And then we'll take an arbitrary x value that satisfies x minus 3 less than delta. We'll go on to show that f of x minus 13 must be less than epsilon. That'll be our overall structure. To get there, though, we want to do a little bit of scratch work. So let's start with our scratch work. And we are trying to show, or we are trying to end up at the point where f of x minus 13 is less than epsilon, right? And so I want to try to manipulate that expression. I'll highlight it here. I want to try to manipulate that expression and try to make it look like it is in the form of this expression, the x minus 3 less than delta. Right? So in my scratch work, I'm going to try to find a connection between this expression and this expression in the hopes that it will illuminate how I might choose my delta. All right, so let's give this a try. So to say f of x minus 13 is less than epsilon, that is equivalent to saying 4x plus 1 minus 13 is less than epsilon. And so that's very similar to, or that's equivalent to 4x minus 12 is less than epsilon. Ooh, and now we start to see, excuse me, now we start to see that this expression is actually kind of similar to this expression. It's just multiplied by an additional 4. So let's really draw attention to that. So this is like 4 times x minus 3 is less than epsilon, right? Because 4 is a positive number, I can just pull it outside of the absolute value sign. Right? And so we're going to end up with an expression that kind of looks like this. X minus 3 is less than epsilon over 4. Now, let's just highlight what we did here. This is all scratch work, but it was starting with this expression. And by doing algebra, we sort of identified and teased out this expression. And I actually realized, whoops, that I wrote my 3 backwards there. Got my 3's and my epsilons mixed up. So that should be an x minus 3. Perfect. So what we're seeing here then is that if f of x minus 13 is less than epsilon, then x minus 3 will be less than epsilon over 4. And because we've just used basic rules of algebra, the reverse is also true. So if I'm able to start with this as an expression, I'm able to end up with this by just doing these algebra steps in reverse. And so what that means then is that when it comes time to actually dive into the proof, this is going to be a good choice for delta. All right, and with that as our observation, let's give this a try. So that was our scratch work up top. Now let's dive into the meat of the proof. So just like before, we want to start with an epsilon. So we want to say start with let epsilon be a positive number. And then we want to define how we're choosing delta. So let's choose delta to equal epsilon over 4. So given any positive epsilon, this choice of delta is a positive delta. And once we've chosen that, we can say then suppose we have an x value in our domain, right? Which again is just all real numbers here. So suppose we have an x value that satisfies f of that satisfies x minus 3. I'm doing it again. X minus 3 is less than delta. What we will ultimately want to show is that f of x minus L is less than epsilon. And we'll fill in the rest. Before we do, I just want to say that at this point, all of our work is sort of highlighted in our scratch work. We're sort of starting at this point, and we're just going to zigzag back to that point there. But for the sake of creating a complete and correct proof, let's go ahead and write that out. So we are assuming that x minus 3 is less than delta. That means that x minus 3 is less than epsilon over 4. But that means let's try writing that one more time. So that means that multiplying both sides by 4, we get 4 times x minus 3 is less than epsilon, i.e. absolute value of 4x minus 12, which I'll just write as 4x minus 13 plus 1, or rather I should say 4x plus 1 minus 13 is less than epsilon. But of course, I can group the 4x plus 1. I can group the 13. So this just becomes absolute value of f of x minus 13 is less than epsilon. And that is exactly what we wanted to show. So we can conclude that the limit of this function as x approaches 3 equals 13. Hooray!